So a line class is a class of a line object. I mean, it's not really that exciting, not shocking. Lines plural is for a collection of line objects, and then spatial lines are a special class of lines. Now, contour lines are not going to be covered yet. Just hold your horses, we'll get there. So when I'm talking about an individual line, I have coordinates which are stored in a matrix, and its subclass is polygon. When I talk about lines, we can see that we have lines and we have ID to keep things organized. So this is like my individual line, and this is the ID on it, so things are organized. And for spatial lines, we go a little bit further, that we have a line, and then we have a bounding box, and then we have a projection. And this extends spatial and spatial lines null. And for subclass, we see that we have a spatial lines data frame. All right, so let's once again do another example. This time we're going to put down some stuff with Japan. So I'm going to use the maps package, the map function. I'm saying, hey, go into the world database, grab the Japan region, but don't plot it. Go ahead and specify my projection. I'm going to say that I want everything in longitude, latitude, and I'm using WGS 84. And then I'm going to convert that map to spatial lines with map tools. I'm going to take the map of Japan, take the coordinate on there, which is important, because notice I didn't specify the coordinates in Japan. And now I can look at the structure. And we can see that in spatial lines, we have our lines, our bounding box, and our projection. I can figure out the length of stuff. And so we can see that there is one actual line in our lines object, and it's of length 34. Now for contour lines, frequently these are stored in spatial lines data frames. All right, so spatial lines data frame, this class holds data consisting of sets of lines where each set of lines relates to an attribute row in a data frame. Frequently, we're going to use this for elevation. So here I'm going to get the contour to spatial lines data frame function in map tools. I'm going to take the contour lines from the volcano dataset, which is a dataset in base R. And here I'm going to start using the slot function. The slot function, what this does, this goes in and this finds a particular object inside my object. So it takes an object, finds a slot, and grabs whatever is inside that slot. And all right, so what we're doing here, we're grabbing data. This is a good way to grab objects when you have more complicated structure. And so here we can see when I grab that, I can see the elevation for each contour line, this is probably in meters. Now here, let's go ahead and specify my projection. And now I want to do convert a map to spatial lines. So I'm going to grab the data of Auckland map gen.dat, specify the projection, and I can see that I have an object of spatial lines. Here's my bounding box. It has not done any manual projection, but I do have the projection stored going on. If I want to look at the slots of lines, I can do that with the slot function. So when I use slot, remember I need to specify the object and then the name. Now let's say that we're interested in particular in some islands on this map. This code here goes through and grabs which ones are the islands. And I decided to store that in a vector and call that the islands vector. And so I can subset that. So this specifies where in my data do I have islands. and I pass that to this, and this will be my spatial lines for islands. So I'm grabbing my spatial lines, subsetting to just the ones that are islands, and now if I want to, I can just look at their lines if I'm interested. Now let's work with spatial polygons. All right, so what this does is this holds polygon topology without attributes. So this says, so this will be something like school districts, counties, countries, two-dimensional regions, not like boundaries. So if I have boundary, that's a line, but if I have a region, that's going to be a polygon. Now, if I have data that I want to connect to individual counties, individual states, I won't have, this will not be the right class for me. We'll get to that class in a moment. All right, so when I talk about spatial polygons, we're going to have polygons for each individual region. We have a plot order, which is important for telling R how to put them down. So it's possible that we have overlap between our polygons. When I have overlap, depending on how I'm plotting things, I can get a very different image going. Here's my bounding box, and here is my projection specified. And so this code goes through and specifies my spatial polygon from the list of lines I've already grabbed. So the previous code grabbed a whole bunch of lines, and now I'm going through and I'm converting those lines over to polygons so that I can plot them as polygons. And this code just kind of slugs through that. The heavy hitters for this is to go individually and grab the polygons. So I take lines, make it into a polygon, and then I make the collection of polygons into a collection of polygons. And I need to keep things organized for this so that I can always connect back to my data later and get the order of plotting. And so now let's take a look. So here is what I've got. All right, there's my map. Now, if I want, I can take those lines we had a moment ago of the islands, I can fill them in gray, and you can see down here that there's some gray islands. These islands correspond to what I pulled out in that previous chunk when I was doing my subsetting. Pretty nifty. This is pretty slick coding. All right, and we can see that we've got 80 lines going. And here we're just going through, and we can do, we can check to see if we have identical objects going on. And we can see that no, we don't. Things that don't match up because I did my subsetting. Here we can see where they do match, and here we can see when they do not. All right, so now we've already tasted polygons a little bit. Let's go a little bit deeper. So now we want to talk about individual polygons and spatial polygons. All right, so a polygon is just like a polygon. Polygons is a collection of polygons. And now spatial polygons, this is a class to hold polygon topology without attributes. So this is not what I want to use if I have data to connect to regions. So here, if I look at the polygon class, we see that we have label points, we have area, we have any holes. Is this region a hole? Yes or no. Ring direction, so the direction of plotting, and coordinates. And this is an extension of a line. If I look at polygons, we can see that we have a list of polygons. So then we have a plot order for each of those polygons. We have a label point, we have an ID to keep things organized, and we have the area of each polygon. And so this does similar work of creating spatial polygons, which are a little bit more specified for spatial data analysis and regular polygons. And we can see that if I take a look at it, of the output from a spatial polygons, we have our bounding box, and we have our projection string. And if I want to go deeper into this, and this gets to be important when I start pulling in data into situations, the plot order, I just take that slot and I can see this is the order by which things are being plotted. And if I want to, I can permute this around. I avoid not changing the order of things if you can avoid it. One thing I could do is I could rearrange the order by the area, but you know, this is just demonstrating that we can do it, really is the point of this. All right, so let's keep on going. This turned out to be a longer video. So now let's do an example involving states. So I'm using the maps package, maps function to say, hey, grab states, don't plot it, but I do want it to be filled in if I'm working with it. And here I'm going to take the state names, and things are not exactly the way, not the way we would normally want it. I've got a colon and some information I don't want. I just want state names. What this is doing is that this is splitting off the part I don't want. And now we want to take a map and we want to convert that map to spatial polygons. So I specify the map, which I said up here. Now for the IDs, I just take the names, which I extracted from the map a moment ago, and then I'm manually specifying the projection. Now here is some data. So what this did, this converted the map to spatial polygons for me. And here this is reading in data connected to each state. And so let's take a look at what doesn't match up in my data set. So here, if I was to actually look at my data set, I would have in here, I have the continental United States, and I have, sorry. Yeah, so we have Alaska, we have Hawaii, we have the United States. This map does not include overall United States, does not include Alaska and Hawaii. And if I want to, I can specify this very nicely. And so this way I'm limiting to just where I have the matching if I want to start putting things together inside a spatial polygons data frame. So now we'll take a look at spatial polygons data frame. All right, so what's going to happen here is that I'm going to have spatial polygons and I'm going to have a data frame. So here I have regions on the Earth. Here I have data connected to each region. So this could be, let's say, each county in the United States, and I could have the number of COVID cases or the population, average age, things like that in a data frame connecting to the region. All right, and here's my data frame. Here, and I've got an abbreviated name, V-score, M-score, and then PC. And if I take my spatial polygons data frame for each of the states, I can see that I've got a data here. I've got my polygons, my plot order, my bounding box, and projection string. So this is very similar to a spatial polygon, but now I have a data slot, and the data connects to each individual region. And you'll notice that if I change up a row name, I'm changing an ID, and you'll notice that everything was lowercase previously. If I put capital A Arizona, everything's going to get messed up. So it won't even let me do it. It just says, hey, there's a problem, there's an error, get out of here. All right, so now let's start doing some subsetting just like we've done before. And so here, what we're going to do, we're going to say, hey, I don't want DC because it's not actually a state. I guess we're not talking about Guam, American Samoa, or let's see, the Puerto Rico or the Mariana Islands either. So I can do my subsetting, put a logical vector inside there to subset my data frame, and it will automatically take care of subsetting the coordinates and subsetting the data frame for me. Very nice. And if I run a summary, it will give me a summary on the spatial polygons part and a summary on the data frame. So I get my bounding box, I get my projection string, and I get a summary on my data frame. That's very nice. All right, this next part, I couldn't find this file, so I just skip over the code. And I'm going to skip over another part later down. Now, spatial polygons. So here, this is very similar. It's a polygon topology. So this isn't like the exciting topology from a math class. This is map topology, which is kind of, I mean, technically it's topology, but it's not, I mean, it's not as thrilled, not as exciting. And so if I want the spatial polygons, I can grab that from the slot. So up here, where did I put it? Oh, there we go. So this is an R data set, and the SP slot in there is a spatial polygon. See that we've got one polygon in there. Oh, sorry, there's multiple. There's one slot with multiple polygons in there, and we can see how many of these are actually holes on there. So remember, if I'm talking about something like a lake, so like Lake Okeechobee in Florida, when I plot Florida, if I want to include that that lake, that's just going to be a hole in there. And so most of the time, it's not a hole, but there are a few times it is. So it might be if there is a region like contained inside another region, like a donut hole, then that will be a hole or a lake or a similar object like that. And here the ring direction specifies the direction that the lines are plotted as we plot the boundary of the polygon. Now, RGeos gives us the option of creating comments on our spatial polygons. And so here I can print those comments. If I want to, I can go ahead and plot my spatial polygon. And we can throw on some text on there. So here I'm just getting the label point. And so we can see the points throughout. And I believe that this has to do with the plotting aspect. I think I made another map of this. And so here's another one, and this is specifying another aspect. And so we can see that these are, I believe it specifies the plotting order. So this is like third in the order, while like 0 is plotted much earlier. Now, when I talk about my grid topology class is a class for defining a rectangular grid of arbitrary dimensions. So something that's important about this is that this is a grid. And so things are a little bit more complicated. That here's the cell center offset, cell size, and cell dimensions, which are all numbers. So now if I want to go ahead and create my grid topology for this bounding box. So notice that what I'm doing, I'm passing a bounding box. I'm giving it a little bit of offset. So here I'm specifying the center of it. Give it a little bit of offset. give it a little bit of, to specify how big each cell needs to be, and then specify the cell dimensions. And I'm going to end up getting my topology grid, and this will specify all the features of that. Now for a spatial grid, this is a class of defining full rectangular grid of arbitrary dimensions. And so here we're going to have our grid topology, our bounding box, our projection force string. So that grid topology that we specified previously specifies the actual features of the grid. And now this specifies where it is and how I print it onto a map. And so I use a spatial grid function, which is in the SP package. I forgot to put that on. And that specifies the object for me. And we can see what's going on. We get, our bounding box, and we get the features of our grid topology. Now we can also look at spatial grid data frame. So after I have my grid, I can specify points onto there. All right, so if I want to connect to each point on my grid, I can take data and connect it using a spatial grid data frame. Now here, if you take the author's code, the author goes ahead and takes a data set that's on the website, converts it over, and then saves it to a format that is useful. So here, the author loads a particular format, saves it, and then loads it. And I'm just following the author's code on this. And then goes through and specifies when we have missing. So if I have a spatial grid data frame, band 1, if it's less than or equal to 0, I want everything to be converted to a missing value. Now, this code, I couldn't get the data set previously. I mentioned that in the video. So I'm just presenting it in case you find the data, but I couldn't find it. I'm not worried about it. So let's take a look at the class of my spatial grid data frame. And of course, it's a spatial grid data frame. And we can look at the grid slot. So here I've got that grid going nicely. We can look at my B box. And once again, we see it. Now notice I never specified longitude and latitude. So it's just assuming that it's going to be X and Y and letting me figure out the coordinates in case I want to do something other than longitude and latitude. Here, object size tells me the memory size of the object. Here I can see that this shows me that almost all of the memory is coming from the data aspect, not the grid itself. And we can run summary on our data frame. And we can convert this to a spatial pixels data frame. So here, this is specifying things in terms of pixels this time. But everything pretty much works out the same thing. That I'm going to have a grid of pixels, and I'm going to have a data frame, and then they connect. And here, we're just kind of digging into individual things. Like we can see how if I use the prod function for product, I can see how big my spatial pixels are. And so for a spatial pixel data frame, once again, I can just work with it like I have with everything else so far in this video, is that I have the spatial aspects of what's going on. Here, I do have a grid going on for my pixels, so that's included here. But I also have a data frame connected to each of those points on the grid. And look at the size. We can also just have individual spatial points and individual spatial pixels. So here, if it's spatial points, it's going to be, and we looked at this previously, class for is regularly spaced points, while spatial pixels is class for defining a pixel, possibly incomplete rectangular grid of arbitrary dimensions. And everything works similar to what we've got thus far. And this is pretty much just repeating the other examples. Now, a raster layer, this is important if you're going to be doing spatial data analysis. A raster is a database organized as a rectangular grid that is subdivided into rectangular cells of equal area in terms of units of coordinate reference system. The raster packages defines a number of S4 classes to manipulate such data. Most of the time, most uses, this is going to be basically a picture that is connected to coordinates. So usually when I look at a raster, it's going to be a picture, so like an aerial map, a satellite map, or maybe a map such as, like a Google map, connected to latitude and longitude. And there's some slick things that the raster package does in terms of memory to keep things manageable. And so we can see that I've loaded this, but it's not actually in memory. That way I don't choke out my machine. I'm only going to call things when I actually use it, when I'm actually going to engage with it. If I want to get cell stats, I can do that to get minimum. Now, something that's interesting is I can take a raster layer object and I can put it in the raster function and work with it again. And we do this so that I have additional options in manipulating my raster object, my raster layer object. And so we can get like our block size, and we can work with writing, and so that we can record what we've got. We can do a for loop across each individual block. And so here, if I just want to plot everything, there we go. And I use the data to get the colors here, so that way it pops. I get more to work with. All right, well, that's all I've got for you. Take care and goodbye.